Welcome to the atmosphere. All right, it's a thin layer of gases that are all mixed together that, stay close to our planet. Well, think about it. Our planet's a pretty big spherical rock thing, and it pulls a lot of gravity. So these air particles, they don't really leave because as far away as some of them might be, they're held to here by our planet because of gravity. And the closer you get to the surface, the more crowded those air particles are, and the further away you get from the surface, the more those particles are spread out because, they're not being pulled as hard by gravity. But here's the thing, even if you take the furthest away particles of air and you consider the distance that those furthest particles of atmosphere are to the surface, on this scale, if you look at this globe, if I put a very thick layer of paint, like house paint, like wall paint, okay, which is not very thick compared to the size of this globe, but if I made a thick layer of paint around this model of Earth, that thickness would represent our atmosphere. So when we say it's a thin layer of gas, yeah, on this scale it's like incredibly thin, but Earth is much larger than this globe. So when we talk about the atmosphere, we're really talking about how it's like, like miles of air above us. So what's in that air? Well, I look at this model. I love this model because this is basically in this jar there is a million little pellets or little dots or little whatever you want to call these things. Okay? And there's static too, so it sticks to the side. But anyway, there's a million of these things, these colored dots. And over here it gives you the breakdown of what's in each color. So out of a million, okay, there's 780,000 yellow ones. Okay? There is 200,000 red ones. Well, this ratio of red to yellow is basically showing you how our atmosphere is constructed. Like what are the gases that are mixed to make what we call air, right? So the yellow represents nitrogen gas, known as N2, okay, capital N with a little 2 at the end. We think of air, we always think of oxygen, but it is not the most common gas found, okay? The red, being approximately 21%, that is the oxygen in their atmosphere. And the other colors that we see, like blue and white and green and black, those represent some of the other gases, like carbon dioxide and things like that. So when we say that there's 9 black pellets in this jar of a million, it's kind of hard to find 9 out of a million. And I've spent plenty of time doing this and staring at it, and I can't. So you might be thinking like those gases not being that common in the atmosphere aren't really important, but yeah, guys, guess what? Our atmosphere is more than a million particles, okay? If I emptied this jar and replaced the lid with just air, there's going to be way more than a million particles in here. So this is like a completely zoomed in, crazy zoomed in thing. Our atmosphere changes. Like I was saying, gravity pulls most of it towards the surface. But as you leave the surface and go further out towards space, the atmosphere is less crowded because gravity is not pulling it as hard to the surface there. But each layer, even though it's basically constructed of mostly the same stuff, it's this ratio throughout the entire atmosphere, no matter how thick or thin it is. There are other characteristics about the layers of the atmosphere that makes it, seem like it has different layers. There's no stop sign or welcome sign that says, now exiting the first layer, welcome to the second layer. That doesn't really happen. But if you flew up, straight up from Earth's surface, up into the atmosphere, and you had a thermometer with you, you would notice a couple of things. Like, at first, the thermometer starts to lower. Then the thermometer, even though you're still getting further away from the surface, the thermometer will start to increase, showing hotter temperatures. And then it's going to go down again, and then it's going to go up infinitely until the thermometer explodes when you're in space. That change of what the thermometer does is basically an indicator that you are in a different, what we call, layer of the atmosphere. The closest one to Earth, the most crowded one with air, is called the troposphere. Okay, then you have the stratosphere, mesosphere, and exosphere as you exit out into space. And you're going to get to know some of these things about the atmosphere and the air that makes it.